Is FHIR adequate to Swamp, and how can it help us in building the Swamp platform? The idea is to share our findings and insights about how FHIR can help us as a software ecosystem for speeding up the development of the Swamp platform, as well as serving as a distributed platform for improving collaboration among the different partners of Swamp. We will show the end-to-end transit of data since it is generated in the sensors up to the point it is showed in a dashboard.
Here we have a sensor collecting data from temperature and humidity. All data are processed by Arduino. This Arduino also have a LoRa shield. So this is a LoRa end device, end node. And this end node send a message to a LoRa gateway. This LoRa gateway are placed in another laboratory 150 meters from here. All the data sent by the end node is collected by the LoRa gateway, and the LoRa gateway send all the messages by MQTT to FHIR.
I am at home, precisely in my backyard, far from Embrapa bureaucracy. That's important. Where I installed some soil probes to play with transmitting data using ZigBee modules. This is the indoor unit that is talking to the probe outside. It's connected to an USB port in my notebook computer here. With this IDE, you can easily develop and transfer Python code to the nodes. At first, I wrote a code to ask sensor values and record data in a text file. The actual version was modified by the Swamp team and sends data straight to the University of ABC FireWire server.
As Jefferson said, the data is then sent to a FireWire service that we're running in our cloud. Our cloud is an OpenStack-based platform, and the message is received by EDAS. EDAS is the FireWire general enabler responsible for interact with different IoT agents. EDAS can communicate with IoT agents using different IoT protocols as MQTT, CoAP, and Sigfox. He received this context and then reassembled the message into an NGSI message. NGSI is a RESTful API used to interaction between the general enablers in FireWire. So EDAS received this message, reassemble them into NGSI, and send it directly to the Orion context broker. Orion is the FireWire general enabler responsible for manage the life cycle of the information. He's responsible for the updates, subscriptions, and Orion will organize this data and store in a Mongo database, where they will be organized and be ready to be consumed by different applications. The data sensor can also be sent directly to Orion. The data collected by the sensors presented by Anda are pre-processed and sent into the NHSI format and then sent directly to the Orion, when they will be also stored, organized, and be accessible. Orion can also be used by external applications, as Professor Ronaldo will present.
A very important thing in Swamp is to get information from external sources, especially weather forecast information. We have developed a very simple application that gets information from a data provider. In this case, openweathermap.org.
we get information from a specific point using the latitude and longitude of this point. This information corresponds to a 5-day, 3-hour forecast information. Based on this information, we build a JSON message that composes a payload that can be stored in our Orion firmware instance here at UFABC.
All the data collected by the sensors and the weather forecast application is stored in the cloud and managed by Orion. In order to validate our platform, we are hosting a web-based dashboard application in the Google Cloud Platform. This will allow us to verify if the Swamp platform is accessible and if the data can be consumed from anywhere. The dashboard shows the data in real time. We are getting the data from the Jefferson sensors and using the Professor Renaud application to get the weather forecast given the sensor's geolocation as a parameter. We can now compare the real-time data with the forecast data. We also have access to water forecast information as rain chance, humidity, wind speed, and even the wind's direction. In the experiment with the Embrapas sensor presented by Andra, the data from the 3 different probes are organized in different structures that can be easily understood. As we can see, since we have different types of sensors, we are also able to analyze the data in different units. All this information can be easily obtained from the Orion Context Broker using the GET and POST methods from the RESTful API and GSI. Another application was developed by our partners from Federal University of Pernambuco. Hosted in the UFPA servers, this application is able to get the context information about the sensors from Orion and present it in an interactive map with precise geolocation.